See, the first question is, if the equation x power 4 minus 4x cube plus ax square plus 6x plus 1 is equal to 0 has 4 positive roots, then the values of a and b. See, when he is talking about 4 positive roots, pen color. Other color. All right. So he is talking about 4 positive roots. So let us say we have let us say x1, x2, x3 x1, x2, x3, x4 be 4 positive roots. So by Vieta's theorem, we can say sum of the roots x1 plus x2 plus x3 plus x4 is equal to 4, and sum of the products taken 2 at a time, which is x1 x2 plus x1 x3 plus x1 x4 plus x2 x3 plus x2 x4 plus x3 x4 is equal to A, and sum of the products taken 3 at a time, that will be x1 x2 x3 plus x1 x2 x4 plus x1 x3 x4 and x2 x3 x4. So this is minus 6, and the product of the roots is x1 x2 x3 x4. This is equal to 1. Now you can see from this we can say that x1 plus x2 plus x3 plus x4 by 4 is equal to 1, and from this we can say that x1 x2 x3 x4 whole power 1 by 4 is also 1. So essentially what we are saying is x1 x2 x3 x4 are 4 positive quantities. Their arithmetic mean is 1 and their geometric mean is also 1. When arithmetic mean is equal to geometric mean, the quantities taken are equal. So therefore x1 x2 x3 x4 all of them have to be equal. So therefore x1 is equal to x2 is equal to x3 is equal to x4. So because their sum is 4 and all of them are equal, so each of them should be equal to 1. So because of that we can make use of this. So each is 1, so you have x1 is equal to 1, x2 is equal to 1, like that you have 6 terms here. So a is equal to 6 is what you get, and here where is B? I think this is B. So this is B. So minus b is also equal to 1, 2, 3, 4. So it is equal to b. B is equal to minus 4. Just make a small note here. There is a typo error. This is b. So this is the first problem. Let us go to the next problem. If the range of values of a for which the roots of x square minus 2x minus a square plus 1 is equal to 0 lie between the roots of x square minus 2 into a plus 1 into x plus a into a minus 1 is equal to 0 is p comma q, then q plus 1 by p square. So the question here is, the roots of the first equation should lie entirely within the roots of the second equation. The roots of the first equation should lie entirely within the roots of the second equation. So the two parabolas should be like this. So let us take the first one, x square minus 2x minus a square plus 1 is equal to 0. So for this, x is equal to b square is 4 So this is x is equal to 1 plus or minus root of 1 minus 1 plus a square. So what you get is x is equal to 1 plus or minus root a square is mod a. So this is what we get as far as the first equation is concerned. Now with regard to second equation, what we get is x square minus 2 into a plus 1 into x plus a into a minus 1 is equal to 0. Here x is equal to so we can now do a little simplification here. So what we get here is x is equal to a plus 1 plus or minus root of a square plus 2a plus 1 minus a square plus a. So which is, say, a square plus 2a plus 1 minus a square plus a. So this is cancelled. So what I get here is a plus 1 plus or minus root of 3a plus 1. So now, because the roots of the first equation are these two roots, the roots of the second equation are these two roots. So we should have the inequality 1 minus mod a less than or equal to 1 plus mod a. Anyway, this we can say this. Mod a being a non-negative quantity, 1 minus mod a should be less than or equal to 1 plus mod a. So these are the roots of the first equation. Now, as far as the second equation is concerned, we can write a plus 1 minus root of 3a plus 1 here, and here we can write a plus 1 plus root of 3a plus 1. We can write like this, because a plus 1 plus root something is a non-negative quantity. So a plus 1 minus root of 3a plus 1 has to be less than a plus 1 plus root of 3a plus 1. So therefore we need to satisfy this inequality. So we need to find the values of a which can eventually satisfy this inequality. So for that, we shall now consider two cases when, because modulus is there, we will consider two cases when a less than 0 and when a greater than 0. So when a is less than 0, when a is less than 0, you have this inequality a plus 1 minus root of 3a plus 1 is less than. When a is negative, mod of that is minus of that. So this becomes 1 plus a less than or equal to 1 minus a less than a plus 1 plus root of 3a plus 1. Now you can see here a plus 1 minus root of 3a plus 1 is less than a plus 1 is trivially valid. A plus 1 minus a non-negative quantity is less than 1 plus a. This is anyway valid. So therefore, we need to only consider this part. So when I consider this, 1 minus a less than a plus 1 plus root of 3a plus 1. So this I need to simplify. So this becomes minus 2a less than root of 3a plus 1. Now, since a is negative, minus 2a is positive. Since a is negative, minus 2a is positive, and right side anyway is positive. So therefore, we can square it on both sides. So 4a square is less than 3a plus 1. So that means we are getting 4a square minus 3a minus 1 is equal to is less than 0. So therefore, this becomes so that means a lies between minus 1 by 4 and 1, but we are saying that a less than 0, so therefore only this portion minus 1 by 4 to 0 we shall consider. Now, next, when a is greater than 0, when a is greater than 0, we have the inequality a plus 1 minus root of 3a plus 1 is less than 1 minus a less than or equal to 1 plus a less than a plus 1 plus root of 3a plus 1. So this is 1 plus a less than 1 plus a plus root of 3a plus 1 is again valid always. So therefore, we can ignore that and need to concentrate only on this part. So here a plus 1 minus root of 3a plus 1 is less than 1 minus a. You can cancel this one and you have 2a less than root of 3a plus 1. You can see here, since a is positive, both sides are positive, you can go ahead and square it. So this is 4a square minus 3a minus 1 less than 0. In other words, what you are getting is again the same thing, a minus 1 into 4a plus 1 is less than 0. That means again a lies between minus 1 by 4 and 1, because a is greater than 1, I can only take this much, 0 to 1. However, a is equal to 0 is valid, this inequality is satisfied for a is equal to 0. In that case, the roots are equal for this inner parabola. So that's the reason why we can take a is equal to 0 also. So therefore, we have minus 1 by 4 to 0, including 0 up to 1. So therefore, the answer for this problem is actually a belongs to minus 1 by 4 to 1, and of course you can now equate p is equal to minus 1 by 4 and q is equal to 1, and then just substitute it here. Alright, so this is the first problem. So when you do that, you have q is equal to 1 and p is equal to minus 1 by 4, that becomes 16. So your answer is 17. This is only to get a numerical value. The actual problem actually ends here. So this problem is actually a very good problem. We are basically focusing on this one inequality to get the value of the parameter a. All right. So now let us see the next problem. The range of values of a for which any solution of the inequality log of x square minus 3x plus 7 to the base 3 by log of 3x plus 2 to the base 3 less than 1 is also a solution of the inequality x square plus 5 minus 2a into x is less than or equal to 10a. So this is 10a. All right. So we'll first talk about this particular inequality. this inequality log of x square minus 3x plus 7 to the base 3 by log of 3x plus 2 to the base 3 is less than 1. So, whenever we are solving any equation or inequality, we need to find out the domain to obtain domain of permissible values basically. So, for that you can see x square minus 3x plus 7, we are talking about real valued functions. So, therefore, x square minus 3x plus 7 has to be greater than 0. However, it is already true because b square minus 4ac is negative. When delta is less than 0, the sign of the quadratic expression is same as the coefficient of x square for every x belonging to R. So, therefore, x square minus 3x plus 7 is positive for all x belongs to R. So, there is no worry with regard to this part. Now, with regard to this 3x plus 2, this 3x plus 2 has to be greater than 0, which is x greater than minus 2 by 3. We also need 3x plus 2 cannot be equal to 1 also because it cannot become 0. Log 1 to the base 3 cannot become, that should not happen. So, it should not be equal to 1 also. So, therefore, 3x should not be equal to minus 1 or x should not be equal to minus 1 by 3. So, whatever the solutions that you get, it has to obey these conditions. So, keeping that in mind, usually it will be a great habit for students when an inequality or an equation is given without making any changes to the given equation or inequality, it will be a good habit to first write this and then start with the solving. Sorry. So, this is log of x square minus 3x plus 7 to the base 3x plus 2 less than 1. Now, you have two cases when the base of the logarithm is lying between 0 and 1 and when the base of the logarithm is greater than 1. So, let us see the first case. When the base of the logarithm is lying between 0 and 1, that is when 3x plus 2 lies between 0 and 1, that is when x lies between minus 2 by 3 and minus 1 by 3, in that case, the inequality becomes x square minus 3x plus 7 has to be greater than 3x plus 2 to the power 1. The inequality symbol will be reversed because it is a decreasing function. So, therefore, this is x square minus 6x plus 5 is greater than 0, and from this we get x minus 1 into x minus 5 greater than 0. So, that means x does not lie between 1 and 5. X does not lie between 1 and 5. So, here let us also look at our conditions. X has to be greater than minus 2 by 3. It has to be greater than minus 2 by 3 and it cannot be equal to minus 1 by 3. No, we are that is one thing, and second thing is we have this requirement minus 2 by 3 to minus 1 by 3. So, this is the acceptable solution for this part. So, next, so considering the intersection of this and whatever you got, and also considering the conditions that we have, x belongs to minus 2 by 3 to minus 1 by 3 is what is the interval that we can take. Next thing is when 3x plus 2 is greater than 1. So, when 3x plus 2 is greater than 1, we have 3x greater than minus 1 or x greater than minus 1 by 3. In that case, we have x square minus 3x plus 7 is less than 3x plus 2, which is x square minus 6x plus 5 less than 0. So, in that case, I get x minus 1 into x minus 5 less than 0. So, that means our condition is that we are x greater than minus 1 by 3, and here you are saying that it should lie between 1 and 5. So, therefore, this interval can be taken. So effectively what you got here is x belongs to minus 2 by 3 to minus 1 by 3, and also 1 to 5. So this is the interval that you got for the first inequality. Now with regard to second inequality, I think we can conclude it here. I'll just use the space. X belongs to minus 2 by 3 to minus 1 by 3 union 1 to 5 is what you got here. So here so now let us talk about the second inequality. The second inequality that is given here is x square plus 5x minus 2ax minus 10 less than or equal to 0. We can see x into x plus 5 minus 10a, sorry, this is 10a. This is 10a. So this is minus 2a into x plus 5 is less than or equal to 0. So we have x plus 5 into x minus 2a has to be less than or equal to 0. So therefore, we should have minus 5 somewhere here, and 2a has to be somewhere here. So therefore, this curve has to come like this. This curve has to come like this. So you have only condition that 2a has to be greater than or equal to 5, or a greater than or equal to 5 by 2. So because even if it passes through like this also, it doesn't matter. So this side we have no condition, because clearly minus 5 is less than minus 2 by 3. The curve has to pass like this, and that side, therefore 2a has to be on that side, and it can at most be equal to 5, or it can be even greater than 5. So a belongs to closed interval 5 by 2 to plus infinity. If this is the these are the values of a, any value of a from that interval, if it is taken, the solution of the first inequality is also a solution of the second inequality. Okay, so let us see the next problem. If 2 power 2x plus 2 minus a into 2 power x plus 2 plus 5 minus 4a greater than or equal to 0 has at least one real solution, then the maximum value of a is. Little unconventional method we shall apply here. The given equation is the given inequality is 2 power 2x plus 2 minus a into 2 power x plus 2 plus 5 minus 4a greater than or equal to 0. So I will just keep 2 power x is equal to t. So obviously t is greater than 0. So I have here 4 into t square minus 4at plus 5 minus 4a greater than or equal to 0. All right. So this is all right. So four t square plus 5 is greater than or equal to 4at plus 4a. In other words, I can write 4a into t plus 1 is less than or equal to 4t square plus 5. So in other words, a is less than or equal to 4t square plus 5 by 4 into t plus 1. A is less than or equal to 4t square plus 5 by 4 into t plus 1. Now the question here is, we need to understand what's required here. If this inequality has to have at least one real solution, then the maximum value of A. So, if this inequality has to have at least one solution, A has to be less than or equal to this much. So, now the parameter A has to be less than or equal to this for different values of t, meaning different values of x. So, this equation will have at least one solution if A is less than this value. This means now this is a variable value depending on the value of t or depending on the value of x. So, therefore, if A is less than or equal to the least value of this expression, then we will have at least one solution. We will have at least one solution. So, therefore, this should be equal to A is less than or equal to the minimum value of 4t square plus 5 by 4 into t plus 1. If this is satisfied, then we will have at least one solution. So, therefore, we will see here, and from here of course a normal calculus approach can be taken. So, let us say ft is equal to 4t square plus 5 by 4t plus 4. So, f dash t is so we will equate this to 0, and you have, so you get 4t into 2t, that is 8t square plus 8t minus 4t square minus 5 is equal to 0. So, from this we get 4t square plus 8t minus 5 is equal to 0. So, 2t plus 5 into 2t minus 1 is equal to 0, right? So, t is equal to minus 5 by 2 or 1 by 2. These are the two values, right? But then t cannot be negative because we said t greater than or equal to 0. So, this is an extraneous value. So, t is equal to 1 by 2 is the only value. You can now do the second derivative and substitute this. You get positive value. So, you can, I am just leaving that part. F double dash t you find out, and for f double dash 1 by 2 you get a positive value. So, therefore, this will correspond to minimum. So, minimum occurs now at t is equal to 1 by 2. That minimum value is 4 into 1 by 4 plus 5 by 4 into 1 by 2 plus 1. So, this becomes 6 by 2 plus 4, 6. So, what you are getting is 1. So, the maximum value, then the maximum value of A has to be equal to 1. So, this is the required answer. So, what you got is A less than or equal to minimum of this is 1. So, what you got is A less than or equal to 1. So, that means A belongs to minus infinity to 1. So, let us go ahead and see the next problem. Here the most important thing is to write this inequality. This inequality is paving the path for getting the solution. So, let us see the next one. The number of ordered pairs AB for which A into x plus 1 whole square, A into x plus 1 whole square plus B into x square minus 3x minus 2 plus x plus 1 is equal to 0 for all x belongs to R. Now, what is this? it should become 0 for all x belongs to R. So it should become 0 for all x belongs to R, means it should vanish identically. So when it has to vanish identically, so let us see this. This is a into x square plus 2x plus 1 plus b into x square minus 3x minus 2 plus x plus 1 is equal to 0. So you should have a plus b into x square plus 2a minus 3b plus 1 into x plus a minus 2b plus 1 is equal to 0. Now this should happen for all x belongs to R. So if this has to be 0 for all x belongs to R, see, basically a quadratic equation can be satisfied at most by two values. But if it has to be 0 for every x belongs to R, then it has to vanish identically. So for it, no matter what x is, it should become 0. So therefore, it is that is possible only when each of these coefficients, are equal to zeros. So therefore, you must have a plus b is equal to 0. You must also have 2a minus 3b plus 1 is equal to 0. You must also have a minus 2b plus 1 is equal to 0. We can take any two equations and solve them, and the values obtained must be satisfied by the third one. See, so what we can do, we have b is equal to minus a from the first one. So if I put it here, b is equal to minus a plus 1 is equal to 0. So you have 2a plus 3a, 5a is equal to minus 1, or a is equal to minus 1 by 5. So as a is equal to minus 1 by 5, b has to be 1 by 5. So these two values have to satisfy this one. So you can see a minus 2b plus 1 is equal to 0, a minus 1 by 5, b is 1 by 5. So minus 2 by 5 plus 1, and this cannot be equal to 0. Therefore, it's not possible for there is no ordered pair a comma b. There is no ordered pair a comma b which can make these three equations simultaneously 0. So therefore, there is no way for this equation to vanish identically. So there are no ordered pairs. So no ordered pairs means the answer that you have to tell is 0. Now how many ordered pairs? 0 ordered pairs. It's not possible. Hope it is understood. What? So let us move on to the next problem. For x square minus alpha plus 2 into mod x plus 9 is equal to 0, to have real solutions, the range of alpha. Here also one unconventional approach we shall try to follow. So here it is given x square minus alpha plus 2 into mod x plus 9 is equal to 0. All right. So now alpha plus 2 into mod x is equal to x square plus 9. Therefore, alpha plus 2 is equal to x square plus 9 by mod x. X square or mod x square makes no difference. So therefore, alpha plus 2 is mod x square plus 9 by mod x, which you can write it as mod x plus 9 by mod x. Now, when we see two positive non-negative quantities, we can think of AM greater than GM inequality. So mod x plus 9 by mod x, their arithmetic mean is this, is greater than or equal to, their geometric mean is mod x into 9 by mod x equal to the power of 1 by 2. So you have mod x plus 9 by mod x is greater than or equal to 3 2s are 6. All right. So that means this is alpha plus 2 is greater than or equal to 6. That means alpha is greater than or equal to 4. Alpha is greater than or equal to 4. So you have 4 to plus infinity. So the interval for alpha is 4 to plus infinity. An excellent problem. Here, unless we consider like this, the interval for alpha cannot be obtained easily. So, next one, the range of values of a for which fx is equal to ax square plus 2 into a plus 1 into x plus 9a plus 4 by x square minus 8x plus 32. Simple problem. See here, fx is equal to ax square plus 2 into a plus 1 into x plus 9a plus 4 by x square minus 8x plus 32. So you can see the denominator b square minus 4ac is negative. So therefore, the denominator is always positive as the quotient of x square is positive. So therefore, for fx to be negative, it is sufficient that the numerator is negative, right? Because the denominator is positive for all x belongs to R, for the function to be negative, it is sufficient that the numerator is negative. So therefore, what do you require is ax square plus 2 into a plus 1 into x plus 9a plus 4, this has to be what? This has to be less than 0 for all x belongs to R. This has to be negative because the denominator is positive for all x belongs to R. Now, this is simple now. So for this, for all x belongs to R means you should have delta less than 0 as well as a less than 0. So the sign of the quadratic expression, the concept is when delta is less than 0, the sign of the quadratic expression is same as that of the quotient x square for all x belongs to R. So therefore, it has to be delta less than 0, a less than 0. So therefore, delta less than 0, if you see, b square minus 4ac has to be less than 0. So let us do a little simplification here. So this becomes minus 8a square plus 2a minus 4a is minus 2a plus 1. This has to be less than 0. So that means we have 8a square plus 2a minus 1 has to be greater than 0. So this is so 1 second, this is so that means a will not lie between minus 1 by 2 to 1 by 4. So that means it has to be like this. So minus infinity to minus half and 1 by 4 to plus infinity. So this option comes correct. Quite a simple problem because you are just taking just one condition, which is delta less than 0. For the numerator, denominator is anyway positive all the time. All right. So let us have a look at the next problem. the number of rational roots of x power 10 minus x power 9 minus 2 is equal to 0. Here we have rational roots theorem. The rational roots theorem says the number of rational roots is equal to plus or minus factors of the constant term by the factors of the leading coefficient. As the theorem is very popular, I encourage students to go through the proof of this theorem to understand why it is coming like that. So this is plus or minus factors of the constant term. You have factors of 2 are 1 into 2, and factors of the leading coefficient is just 1. So we have 1, 2, minus 1, minus 2. Among these numbers, which will satisfy the given equation? So you have x power 10 minus x power 9 minus 2 is equal to 0. If I put x equal to 1, it doesn't satisfy. If I put x equal to 2, obviously it doesn't satisfy. If I put x equal to minus 1, it will satisfy. So therefore, minus 1 is the only rational root. Minus 1 is the only rational root. Once again, I am telling the number of the rational roots. I'll write it a little more clearly here. Rational roots are to be chosen from the numbers that you get from here. So rational roots are among the numbers that you get here, and among them minus 1 is the only fitting thing. So minus 1 is the only rational root. So a number of rational roots are 1. So go through the proof of this theorem to appreciate the idea behind this. Yeah, it's a very simple problem. Let alpha comma beta be real roots of x square plus kx plus k square plus 2k minus 4 is equal to 0. Now the maximum value of alpha square plus beta square is dash. So you have alpha plus beta is minus b by a, and alpha beta is k square plus 2k minus 4. So therefore, alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. So therefore, k square minus 2 into k square plus 2k minus 4, which becomes minus k square minus 4k plus 8. Okay. So then the maximum value of this expression is 4ac minus b square by the maximum value of this expression is 4ac minus b square by 4a. So which becomes 32 plus 16 by 4. So what I get is 48 by 4, which happens to be 12. So the maximum value is 12. So quite a simple problem. Yeah. Basically, there is no complicated idea involved in this problem. If a, b are the roots of the quadratic equation, 2 minus is also a straight problem. 2 minus b into x square plus b square minus 3b into x plus b square is equal to 0. B not equal to, b not equal to 0, then what? All right. So here we shall consider the sum of the roots. So a plus b, because a and b are the roots. So sum of the roots is a plus b is minus b by a, which is 3b minus b square by 2 minus b, that is a plus b. Also ab, product of the roots, is b square by 2 minus b. So since b not equal to 0, I can cancel one b and write this as a into 2 minus b is equal to b. So you have 2a minus ab is equal to b. So you have 2a is equal to ab plus b. So a is equal to ab plus b by 2. ab plus b by 2. So you can see AB are in AP from this. We can say AB are in AP. They form an AP. So AB are in AP. You can choose this. Now, when it comes to this one, since B is not equal to 2, I can just multiply both sides with 2 minus B to get A plus B into 2 minus B is equal to 3b minus b square. So therefore, I have 2a minus ab plus 2b minus b square is equal to 3b minus b square. So as such, we get 2a minus ab minus b is equal to 0. So what we get here is 2a is equal to ab plus b. 2a is equal to ab plus b. So if I raise this to the power 2, 2 power 2a is equal to 2 power ab plus b. So which I can write as 2 power a whole square is equal to 2 power ab into 2 power b. This says that 2 power ab, 2 power a and 2 power b, they form a GP. So this is correct. So we have two options which are correct here. All right. We shall now go to the next problem. Here is an interesting problem here. This is only to fit into one particular type of question. We have just written these things, but keeping that point aside, enjoy the problem first. A plus b plus c plus d plus e is equal to 15, and ab square c cube d power 4 e power 5 is equal to some number 120 whole cube into 50. Okay, all right. So here, these are all positive quantities. Whenever these positive quantities are given and these things are given, a great possibility is the AM greater than GM inequality. So, to consider that AM GM inequality, here you have a big thing here, AB square C cube D power 4 E power 5. Alright, because of the presence of such a product here, we shall consider A B by 2, B by 2, C by 3, C by 3, C by 3, D by 4, D by 4, D by 4, alright, plus E by 5, E by 5, E by 5, 5 times. So we shall consider, okay, 15 positive quantities, you can see. these 15 positive quantities, their arithmetic mean is whole divided by 15 is greater than or equal to their geometric mean. Their geometric mean is A b by 2 whole square, c by 3 whole cube, d by 4 whole power 4, e by 5 whole power 5, and whole to the power of 1 by 15, whole to the power of 1 by 15. So their arithmetic mean is greater than or equal to their geometric mean. So this is how you consider. After all, the numerator is nothing but a plus b plus c plus d plus e and nothing else. So the numerator, it is equal to 15. A plus b plus c plus d plus e is given as 15. As such, this is 15 by 15 and nothing else. Greater than or equal to. Now we shall see that side. So you have there a b square c cube e power 4 and e power 5 divided by 2 square 3 cube 4 power 4 5 power 5 whole power 1 by 15, right? Yeah, whole power 1 by 15. Let me check again. I have there 2 square, 3 cube, 4 power 4, 5 power 5, whole power 1 by 15. All right. So this is, you got one here. So this is greater than or equal to a b square c cube d power 4 e power 5. This value is given as 120 cube into 50 divided by 2 square 3 cube 4 power 4 5 power 5 whole power 1 by 15. As we have prime factorization as the denominator, we shall go ahead and do prime factorization for the numerator as well. So therefore, so 120 is what? 8 into 15. So this is 2 cube into 3 into 5. And 50 is 2 into 5 square. So you have 2 power 4, 3, 5 cube. So I must be making some simplification error. I have 120 cube, right? Yeah, I have 120 cube. So it is a whole cube here. Yeah. So that means I have here 2 power 9, 3 cube, 5 cube, 2, 5 square. So all right. So this becomes 2 power 10 and then 3 cube, 5 power 5. 2 power 10, 3 power 3, 5 power 5. Hope I am doing it right. So here, so this is 1 greater than or equal to the numerator is 2 power 10, 3 cube, 5 power 5, and I have denominator here 2 power 8, 2 square. So 2 power 8 and 2 square. 2 power 8 is this one and 2 square here. So 2 power 10 again, and here 3 cube and 5 power 5. So as they match, hopefully the simplification is correct. So therefore, this is becoming 1 again, right? So you have 1 is equal to 1. So therefore, the arithmetic mean is becoming equal to the geometric mean. So when the arithmetic mean is becoming equal to the geometric mean, the quantities considered are all equal. So therefore, whatever the quantities that you have considered, they are all equal quantities. All right. So what quantities did we consider? All these quantities. So A is equal to B by 2. You don't have to write B by 2 again. C by 3 of course, and then D by 4, and then E by 5. So actually the problem gets over here, but then to put it into the perspective, let us say we equal to K. So we have A is equal to K, B is equal to 2K, C is equal to 3K, D is equal to 4K, and E is equal to 5K. So what do we want? All right. So for K is equal to 1, we can have simply A is equal to 1, B is equal to 2, C is equal to 3, D is equal to 4, and then E is equal to 5. So for that, A square plus A square plus B square plus C square plus D square minus E square. A square is 1, B square is 4, C square is 9, D square is 16, E square is 25. So what we get is 5. So the final answer is 5. So then the value of n for which this happens. So n is equal to 5 or something. Yeah. All right. So this is the required answer. So this thing, if whenever you have to consider this kind of things, you just look at the product and then cut these quantities like this. If you see B square, write B by 2, B by 2. If you see C cube, C by 3, C by 3, C by 3. That helps when your plan is to use AM greater than GM. All right, we'll see the next problem. What is this? If the equation 3x power 4 minus 18x cube plus bx square minus 8qx plus 3q is equal to 0, this equation has only positive real roots when the value of p by q. Again, only positive real roots. All right. Let x1, x2, x3, x4 be, let x1 let x1, x2, x3, x4 be the positive real roots. All right. So by Vieta's theorem, first we will write down there some taken 2 at a time, all that. So x1 plus x2 plus x3 plus x4 is equal to 18 by 3, so which is 6. And some of the products taken 2 at a time will be x1 x2 plus x1 x3 plus x1 x4 plus x2 x3 plus x2 x4 plus x3 x4. Just say I need to get how many? 4C2 terms. Yeah, 6 terms, right? This has to be minus b by a and then have c by a, p by 3, and then some of the products taken 3 at a time, that will be x1 x2 x3 plus x1 x2 x4 plus x2 x3 x4 and x1 x3 x4, x1 x3 x4. This is minus 8q by 3. I get 8q by 3 because you have minus b by a, c by a, again minus d by a. So minus of minus 8q by 3. All right. And then x1, x2, x3, x4. This is equal to product of a plus 3q by 3. 3q by 3, which is q. So let this be in front of us. We'll see how to make use of some of them. So now here, It doesn't appear because you can see here x1, x2, x3, x4 is q. We don't know how much it is. And here also this is p by the, except the first one we don't have a number here. So to use the idea am greater than gm. Shall we try am greater than hm? So we'll explore the possibility of using am greater than hm. So arithmetic mean of course is x1 plus x2 plus x3 plus x4 by 4 is greater than or equal to, harmonic mean is 4 by, right, 1 by x1 plus 1 by x2 plus 1 by x3 plus 1 by x4. I just check the question once. Could be correct only, let us see. So this is x1 plus x2 plus x3 plus x4 is 6, is greater than or equal to 4 x1, x2, x3, x4 by, oh, all right, the q will get cancelled. Yeah. So this is x2, x3, x4 plus x1, x3, x4 plus x1, x2, x4 plus x1, x2, x3. So you can see here 3 by 2 greater than or equal to 4q by this value, we know it as 8q by 3. 8q by 3. So as q is getting cancelled, it's working out here. So this is 3 by 2 greater than or equal to 3 by 2. What is happening? So it is equal to. So therefore, arithmetic mean is greater than or equal to, harmonic mean is working here. am greater than or equal to gm greater than or equal to hm. Equality sign applies when all the quantities are equal. But usually am greater than or equal to gm prevails. We use that most of the time. However, there can be times when am can be equal to hm. When am becomes equal to hm, also the same thing, the quantities have to be equal. So therefore, in this case also the quantities that are taken are all equal. So therefore, if you consider these quantities, each of them are just the same. So if each of them is alpha, we have 4 alpha is equal to 6. Therefore, alpha is equal to 6 by 4, which is 3 by 2. And similarly, you can see here alpha square added 6 times is equal to p by 3, and you have alpha is equal to 3 by 2. So 9 by 4 is equal to p by 3. So therefore, you have this is p is equal to 9 into 9, 81 by 2. P is equal to 81 by 2. So this is the value of p. And then we need to get the value of q also. So for that, so here alpha cube added how many times? 1, 2, 3, 4 times. 4 alpha cube is equal to what? 8q by 3. 8q by 3. We'll get rid of 4 here. So alpha is 3 by 2. So this is 27 by 8 is equal to 2q by 3. All right. So q is equal to 27, 3 is 81 by 16. So q is equal to this value. What do we want now? P by q. We want p by q. So p by q is equal to 81 by 2 by 81 by 16. So this 81 is cancelled, this is cancelled 8 times, so you get 8. So the required answer is 8. So here, even though am greater than equal to gm we have not applied, is not useful, It's not, we couldn't use it because of this Q basically. We could use AM is equal to HM to get the values. Hope is understood. And AM equal to HM also, bear in mind, it is it's an important thing basically. Yeah. All right. So the summation problem, basically when we see a summation problem, think of telescopic cancellation. So somehow after finding the general term, you need to somehow split up into a difference of two terms. So let us work on this. So here, if I see the top terms, the terms on the numerator, we have 5, 8, 11, 14 and so on. Therefore, the rth term will be a plus r minus 1 into common difference is 3. So, I get 3r plus 2. I get 3r plus 2. Then we have, you see this 1, 2, 3. So, like that 1 square, 2 square, 1 square here, 2 square here, 3 square here, like that. So, you get r square. And then 2 square, 3 square, see this 2 square, 3 square, 4 square and so on. And this has to be r plus 1 whole square when it comes to r term. Now, these factors 3, 4, 5 and so on. So, when it comes to r term, it has to be r plus 2. So, therefore, TR has to be 3r plus 2 by r square into r plus 1 whole square into r plus 2. Now, the only step that is really relevant here, that's important, is the way you split this. So, this can be written as, TR is equal to 1 by r square into r plus 1 minus 1 by r plus 1 whole square into r plus 2. You can just see, when you are working on it, what you must do is to make certain possibilities, look at certain possibility and see what works. See, typically if I take the LCM here, whether it works or not, we can check once. So, you have r square, r plus 1 whole square into r plus 2. So, you have r plus 1 into r plus 2 comes here minus r square will come here. You can see in the numerator r square plus 2r plus r, 3r plus 2 minus r square. So, you get your 3r plus 2 in the numerator. So, therefore, the way that we split, it works. So, just a second, I'll just clear this. All right. So, this is, will first, whenever you need to find the sum to infinite number of terms, it is necessary that you find the sum to n terms and then limit as of Sn as n tends to infinity. That is how you should do. So, Sn, that is, we are talking about sum to n terms, is sigma r is equal to 1 to n, and I occasionally see one mistake. Instead of writing the rth term, children used to will generally be writing the nth term and apply sigma to the nth term and writing n is equal to 1 to n, they write that. Okay, it doesn't look tidy, don't do that. You just take the rth term and let r range from 1 to n. So, 1 by r square into r plus 1 minus 1 by r plus 1 whole square into r plus 2. So, this is 1 by 1 square into 2 minus 2 square into 3 plus 1 by 2 square into 3 minus 1 by 3 square into what? R is equal to 2. R is equal to 2. I get 4 here. Plus etc. etc. For R is equal to n, I get 1 by n square into n plus 1 minus 1 by n plus 1 whole square into n plus 2. Oh, what happened? I think I have touched the end of the n plus 2. Let me. So n plus 1 whole square into n plus 2. So now you can see these terms get cancelled telescopically. If the first term remember, if the first term remains, here the last term will remain. So these terms will get cancelled. So what you get here is 1 by 1 square into 2, which is half, minus 1 by n plus 1 whole square into n plus 2. This is what we get here. So which is 2 into n plus 1 whole square into n plus 2. So you get n plus 1 whole square into n plus 2 here minus 2. So this is what is sum to n terms. Now we need sum to now we need limit of Sn as n tends to infinity. So this is limit of n plus 1 whole square into n plus 2 minus 2 by 2 into n plus 1 whole square into n plus 2. So as n tends to infinity. So polynomial by polynomial of the same degree. So the answer is leading coefficient by leading coefficient in limits you have done several times. So therefore, the answer here is n cube coefficient here is 1 and here n cube coefficient is 2. So the sum to infinite number of terms is 1 by 2 and therefore B is the correct answer. All right. Yes. All right. We shall now go to the next problem. Oh, if 4a square plus 9b square plus 16c square is equal to 2 into 3ab plus 6bc plus 4ca, then ABC are in what? AP, GP, HP, AGP. Is a simple problem, but if the correct simplification approach is, if it is not thought of, it can actually spoil the time. So take 30 seconds to think of it. So here 4a square plus 9b square plus 16c square minus 6ab minus 12bc minus 8ca equal to 0. All right. Now this I will write half into 8a square. This is the most important step here. 18b square 32c square minus 12ab minus 24bc minus 16ca. All right, this is equal to 0. So this is half into 2a minus 3b whole square plus 3b minus 4c whole square plus 4c minus 2a whole square is equal to 0. You can check once. Basically, the thought for you also will come because in your school days you have learned if a square plus b square plus c square minus ab minus bc minus ca. What you will do? 1 by 2 into twice this. and then you write half into a minus b whole square plus b minus c whole square plus c minus c whole square. So exactly the same thing we have done here, nothing else. So therefore, but if you want, you can make one check. 4a square here, and here 4a square, so 8a square. So you have 9b square here, 9b square, 18b square, and you have 16c square and 16c square, so 32c square, and you have 12ab minus 12ab here, 12 minus 24bc here, and minus 16ca here. So it's taken care of. So sum of three perfect squares can't be 0 unless those quantities are equal. So this everyone knows. So therefore, at once you are getting 2a minus 3b is equal to 0, and 3b minus 4c is equal to 0, and 4c minus 2a is equal to 0. So what's happening? 2a is equal to 3b, and 3b is equal to 4c, and 4c is equal to 2a. So this is what is happening. So you have 2a is equal to 3b is equal to 4c, right? 2a is equal to 3b is equal to 4c. So this is what it is. Let us say it is equal to k. So you have a is equal to k by 2, b is equal to k by 3, and c is equal to k by 4. So therefore, a, b, c are in what he is telling. So you have k by 2, k by 3, k by 4. You can at once see that they form a HP, right? So they form a HP. So the answer is C. All right. Let us see the next problem. Alpha, beta, gamma are the positive real roots of the equation x cube minus 6x square plus ax plus b is equal to 0. Then the minimum value of 3 by alpha plus 1 plus 3 by beta plus 1 plus 3 by gamma plus 1. So therefore, we shall write alpha, beta, gamma are the positive real roots. Again, AM, GM, HM could play a role. Alpha plus beta plus gamma is equal to minus b by a, which is 6. Alpha beta plus beta gamma plus gamma alpha is equal to c by a, which is a. And alpha beta gamma minus b. This is what it is. All right. Let it be like that. Here, A, B, like in that earlier problem, here also we have an issue. This is not known and this is not known. Let me consider 3 by alpha plus 1 plus 3 by beta plus 1 plus 3 by gamma plus 1 be 3 positive quantities. Their arithmetic mean is this. No way to consider GM. It doesn't work out. Let us see HM. So 3 by 1 by this much. 1 by this much is alpha 1 by 3. Alpha plus 1 by 3. 1 by this much. So beta plus 1 by 3. And 1 by this much, which is gamma plus 1 by 3. So therefore, you have 3 by alpha plus 1 plus 3 by beta plus 1 plus 3 by gamma plus 1 is greater than or equal to, ask this 3 to go the side. So 9 here, 3 into 3, 9, and this 3 also will come up. You have alpha plus beta plus gamma plus 3. So this is becoming 3 by alpha plus 1 plus 3 by beta plus 1 plus 3 by gamma plus 1 is becoming equal to 9 into 3 by alpha plus beta plus gamma, we have 6. So 6 plus 3, 9. So this is cancelled. So we have 3 by alpha plus 1 plus 3 by beta plus 1. Oh, if x by 2x plus y plus z plus y by x plus 2y plus z by x plus y plus 2z less than or equal to p, x, y, z are all positive quantities, then what's for p? All right. That p and all we don't bother about. We think of the inequality first. Not always AM, GM, HM could be our savior. At times we need to think completely differently. A very different, actually this problem, I just gave it here. This one actually doesn't belong to this. Even though you can see, there is no way to tell that this is a calculus problem, but it is in fact. So let us see how it is. I will just consider, let x plus y plus z is equal to s. All right. Then I will choose a function so that x by 2x plus y plus z will become x by x plus s plus x, like that we can write. So we can write that later. I will now consider, I will choose a function. Now this is one most important thing. Choose a function f maps 0 to infinity to 0 to infinity such that f of t is equal to, okay, t by s plus t. I am just choosing a function f t is equal to t by s plus t. Now this function is continuous and differentiable. F dash t is s plus t so this is f dash t is s by s plus t whole square. So f double dash t is s into minus 2 into s plus t whole power minus 3. You can see it is negative. So f double dash t is negative. Therefore, the function that I have chosen, because the second derivative is negative, this is concave. The function that you have taken is concave, right? So you have the Jensen's inequality. We are not making use of AM greater than GM inequality. Instead, we are making use of Jensen's inequality. So what it says, the general Jensen's inequality is that a function f is said to be concave in an interval I if for any x1 comma x2 belonging to I, alpha 1 alpha 2 greater than 0, f of alpha 1 x1 plus alpha 2 x2 by alpha 1 plus alpha 2 is greater than equal to alpha 1 fx1 plus alpha 2 fx2 by alpha 1 plus alpha 2. If this is the definition for a concave function, which is also called as the Jensen's inequality. All right. So because of that, f of, I will choose f of alpha 1 x1 plus alpha 2 x2 plus alpha 3 x3 by alpha 1 plus alpha 2 plus alpha 3 is greater than equal to alpha 1 fx1 plus alpha 2 fx2 plus alpha 3 fx3 by alpha 1 plus alpha 2 plus alpha 3. Alpha 1, alpha 2, alpha 3 all greater than 0. So now how do we choose? I will choose alpha 1 is equal to alpha 2 is equal to alpha 3 is equal to 1. This is what I will choose, and I will also choose in place of x1 I will choose x, in place of x2 I will choose y, and in place of x3 I will choose z. so that this becomes f of x plus y plus z by alpha 1 plus alpha 2 plus alpha 3 is equal to 3 is greater than or equal to alpha 1 fx1, that is f of x plus f of y plus f of z by 3, because alpha 1 is equal to alpha 2 is equal to alpha 3 is equal to 1. This is our choice, and choosing this function is also our choice. Well, you must see the way in which the problem is getting solved. F of x plus y plus z is equal to s. So f of s by 3 is greater than or equal to, now what is fx? It is x by s plus x plus y by s plus y plus z by s plus z. Okay, and we'll just send this 3 this side. So now this is 3 into f of yes, now here f of s by 3. So in this, if I put in place of t, if I put s by 3, this 3 I have written here, and s by 3 by s plus s by 3 is greater than or equal to x by s is x plus y plus z. So this becomes 2x plus y plus z. See, your inequality is taking shape. Notice this. X plus 2y plus z plus z by x plus y plus 2z. So this is, see, this is 4s by 3, s by 3 by 4s by 3. So you get, so here what you are getting, s by 3 by 4s by 3. So 3 cancel, s cancel, you get 1 by 4. So 3 into 1 by 4. So 3 by 4 is greater than or equal to x by 2x plus y plus z plus y by x plus 2y plus z plus z by x plus y plus 2z. So that means this is less than or equal to 3 by 4. The maximum value is 3 by 4. So this is less than or equal to p. So p is 3 by 4. That's only to get one integer there. Just a second, a small technical glitch. Down. ఈ ప్రాబ్లం సొల్యూషన్ పోయింది, మళ్ళీ చేయనా? This was actually giving trouble. All right, anyway, you can see the solution by going back a little. Here somehow I lost that on the screen. So what you got is, so what you got is P is equal to 3 by 4. Therefore, 4P is equal to 3. So, sorry for the inconvenience. I am not able to show the whole problem once again, but you can just go back a little and see the solution once again. The thing here is that in this inequality, we are two things we are doing. One is we are choosing a function by looking at the terms of the terms there, and of course, calculus in the sense we have just used only differentiation. We just verified the function that we have taken as a concave graph or a convex graph. That was our interest. So accordingly, we can write the Jensen's inequality. So this is basically a departure from the AM, GM, HM inequality. At times, certain things like that also can appear basically. Yeah. All right. So let us go to the next problem. If 11 power n plus 2 into 11 power n minus 1 into 10 plus 3 into 11 power n minus 2 into 10 square plus 4 into 11 power n minus 3 into 10 cube and so on, this summation plus so on is equal to k into 11 power n. We'll divide both sides with 11 power n, so that we get 1 plus 2 into 10 by 11 plus 3 into 10 by 11 whole square plus 4 into 10 by 11 whole cube plus so on. So let Sn is equal to this much. I will consider the nth term. The nth term is n into 10 by 11 whole power n minus 1. So you can at once see that this is an arithmetico-geometric progression. So therefore, identify the common ratio of the GP part, which is 10 by 11, multiply that Sn with that, 10 by 11 Sn is equal to, you get 10 by 11 plus 2 into 10 by 11 whole square plus 3 into 10 by 11 whole cube plus so on plus n into 10 by 11 whole power n. So if you subtract 1 minus 10 by 11 Sn is equal to 1 plus 10 by 11 plus 10 by 11 whole square plus 10 by 11 whole cube plus so on plus minus n into 10 by 11 whole power n. All right. So you have from here to here, you have n terms, because these are n terms. So 11 minus 10 is 1 by 11. Sn is equal to, now it's a clean GP. So A into 1 minus r is less than 1, r power n by 1 minus r minus n into 10 by 11 whole power n. So this is 1 by 11 Sn is equal to 11 minus 10. So this is 1 by 11. Let this 11 be taken to the numerator. 1 minus 10 by 11 whole power n minus n into 10 by 11 whole power n. This is, and what did I do? Yeah, this 11. So this 11 also we can send it this side, and we can remove this 1 by 11 here. All right. So this is what is the sum to n terms. We need to get the sum to infinite number of terms. So therefore, limit of Sn as n tends to infinity is equal to, now you can see as n tends to infinity, this becomes 0 and this becomes 0, because this is lying between 0 and 1. So you have 11 square into 1 and this is 0 anyway. So what you get is 11 square, which is 121. Nice to write with yellow color instead of red color here. 121, right? So which is 11 square, okay? N is equal to 2 and K is equal to 1 are the values that you can get here, okay, right? So let us see the next problem. If x cube plus ax plus 1 is equal to 0, x cube plus ax plus 1 is equal to 0 and x power 4 plus ax square plus 1 is equal to 0. If they have a common root, then the value of a plus 2 is equal to 0. So let alpha be the common root here. Let alpha be the common root. Be the common root. Alpha be the common root. So can alpha be equal to 1? No. See, alpha cannot be equal to 1, right? Let me check the question. So here alpha cube plus alpha no, we can't say about 1. We can say alpha cannot be equal to 0, we can say, because 0 cannot be a root to any of them. So alpha cube plus a alpha plus 1 is equal to 0. Okay. So if I multiply this with alpha, alpha power 4 plus a alpha square plus alpha is equal to 0. And for this equation, it is alpha power 4 plus a alpha square plus 1 is equal to 0. So because alpha is a common root, these two are solvable. When I subtract, so these two get cancelled, I get alpha minus 1 is equal to 0. So that means I get alpha is equal to 1. So alpha is equal to 1. The common root I got it as 1. And so alpha is equal to 1 means if I substitute here 1 plus a plus 1 is equal to 0. So what I get is a is equal to minus 2 or a plus 2 is equal to 0. So the required answer is a plus 2 is equal to 0. So that's the problem. Okay. I think we're done with this. So the problems that we have discussed today, go through them, and I wish you all the very best for your upcoming main exam and also the advanced exam that you are going to take up. All the very best.